Hello, welcome to next video. We were solving GATE 2012 Production Industrial Engineering paper. Okay. Now in this video, starting with question number 46. The question number 46 is: on an average, there are 30 customers in a queue. If the arrival rate of the customer into the system is 16 customers per hour and an average 32 customers leave the system per hour, then the average number of customers in the system is option A 16.5, B 30.5, C 32, and D 46. Okay, so the arrival rate is your 16 customer per hour. Okay, and service rate is your not known. Okay, and average number of system in queue is your 30. Okay, so the uh, average number of the system means customer. Okay, average number of customer in queue is your lambda square divided by mu 1 minus mu minus lambda. So lambda here is 16 and this is your equal to 30. So we can find out mu. So mu is your service rate. Okay, if mu is 30 number of customer in queue. Okay, if mu is your 30 number of customers in queue. Okay, uh, so this as this mu is for 30 number of customers in queue. Okay. Now the number of customer in queue is 30. Okay. So length of the queue is 30. It also includes 32 customers which leave the system or whatever. Okay. So the length of the queue is your 30. Okay. And your lambda or the arrival rate is your 16. Okay. So this is the waiting time for each person. Okay, this is your length of queue. Each customer shows 30 and this arrival rate is just 60. Okay, so this is waiting time in queue. Okay, and waiting time in system is nothing but WQ plus 1 by your service rate. Okay, so this is your uh, the waiting time in system is your 1.9355. So it is waiting time in queue plus the time that is uh, during which it is the person has been serviced. Okay. So the number in system is just nothing but lambda arrival rate into waiting time in system. Okay. So this is your answer is your 30.96. Okay. So it is 30.5. So option is D. Next. Data for four jobs that need to be processed on a single machine are given below. Job PQRS, processing time 12 for P, 9 for Q, R 21 for R, and 10 for S. Due dates are 20, 40, 30, and 90. All the four jobs are available at time 0. If the jobs are scheduled using earliest due date EDD algorithm, then the job with maximum tardiness is option A P, option B Q, option C R, option D S. Okay. So arranging these jobs according to earliest due date. Okay. So earliest due date is for S, then for P, then for R, then for S. Okay. So the processing time for S is 10. Okay. Due date is 90 and delivery will be after 10 days or 10. So delivery will be after 10 days. Okay. And processing time for P is 12 and due date is 20. So the delivery will be after 10 plus 12, 22 days. Okay, so there will be 2 days of tardiness or lateness. Okay, and for R it is the processing time is 21, due date is 30. So it will be delivered to the delivered on 42nd day. Okay, so tardiness is 12, and for Q the processing time is 9 and due date is 40. So, and delivery date will be submission of all this. Okay, 51. So tardiness will be 11. So maximum tardiness will be for R. Okay, so all options C is the next. Question number 48 and 49. Two steel truss members AC and BC having cross-sectional area of 100 mm square are subjected to horizontal force as shown in figure. All joints are hinged. So this is the figure, and this is force F, and this is A and B joint. These joints are hinged. This angle is 45, this angle is 60. Okay. So this point is C. Okay. There are two questions based on this. The maximum force F in kilonewton that can be applied such that the axial stress is any of the truss members does not exceed 100 MPa. Option A 8.17, B 11.15, C 14.414, D 22.3. Okay. Question number 49. If 1 kilonewton, the if F is 1 kilonewton, the magnitude of vertical reaction bulk at point B in kilonewton is 0.63, 0.32, 1.26, 1.46. Okay. So this is your figure where I force is acting. Okay. And the maximum stress and the cross section area of each load is 100. Okay. And maximum stress is of 100 MPa. Okay. So to find out the stress in these two members, first of all we have to find out the force carried by these two members. Okay. So F is your sorry, F is in this direction, and this angle is 105, this angle is 135, this angle is 120. Okay, okay, these angle can be found out. Okay, because we know these angles. This is 45, so this will be automatically 135, and this is your 60, so this will be automatically 120. Okay, then using the Lamiture, so F by this sine for 105, and FA by this sine, and F would be by this sine. Okay, we get FA as 0.8965F and FB as 0.732. Okay, we can see that the maximum force is occurring in this A member. Okay, in A1. Okay, so the maximum stress will also occur in this member. Okay, so the stress is your 100 MPa. So FA by area is your 100 MPa. Okay, so putting the value of FA is your 0.8965 and area is 100. Okay, this is 100. So from this we can find out F. So F is your 11.15. Okay. Now to find out the reaction. Now second question is, if F is 1 kilonewton, the magnitude of the vertical reaction work in the at the point B. Okay. So to find out the reaction at B, okay, we are having that RB is the vertical reaction. RB is the, so this is the vertical reaction, and it will be the component of that FB that is worked in this BC road due to this F. Okay, and this FB is nothing but 0.732 F. Okay, and F is your 1 kilonewton. Okay, so and R, so the vertical reaction at B will be your FB into cos 30, because this is making this is FB and this is making it 30 degrees angle with this vertical normal. Okay, okay. This is your 50. This is so vertical force will be in this direction. Okay, and the vertical reaction. Okay, so the vertical reaction will be your uh, this is vertical, so then this angle is your 30 degrees. This is one, the vertical reaction will be your FB cos 30. Okay, so answer is your 0.633. Okay, so here this is your horizontal, this is your vertical, and with vertical it is making an angle 30 degrees. Okay, mm, this is your 60, then this will be your 30. Okay, so It is making 30-degree angle. So it will be FB cos 30. So answer is your 0.633 kilometers. Okay. Next, data for plain milling operation is are given below. Length of workpiece 200 mm, cutter diameter 100 mm, number of teeth 4, cutter speed 100 rpm, speed 200 mm per minute, depth of cut 2 mm, Total total clearance 5 mm. The mean undeformed chip thickness in micron is option A 142 and option B 100, option C 71, option D 50. The machining time for single pass in second is A 60, B 56, C 126 and D 150. Okay, so we will see question from here. Question number 50 and 51 and solve it. Okay. So this is the question and this is the solution. Okay. Here the given things are length of a tree, cutter diameter, number of teeth, cutting speed, speed. Okay. Now speed is just 200 mm per minute. Okay. So this is your speed is your 200 mm per minute. Okay. And N is the RPM, the cutter, and Z is number of teeth. Okay. So if we divide this F by N, okay, then the field will become in mm per revolution because this is the RPM. Okay, and then we divide this F by N by Z, then the field will become uh, per teeth. Okay, so this is field per teeth. Okay, so this is your field per teeth. Okay, and this is shown by the figure. Okay, so in one teeth, the the feed is equal to this AC. Okay, so this is AC. This is feed per teeth, and in one tooth, it keeps the machining has been done to this length. Okay, so AB is the maximum chip thickness. Okay, and this is your uncut thickness. Okay, and beta is the angle included by contact. Okay, so this is your angle. This is your vertical. Okay, and the cutter start from here and go like that. Okay, so this is your angle included by contact. Okay, contact arc by one tooth. Okay, this is your one. Okay, so cutter start from here, cut like this, and then go to this. So cut start from here. Okay, and then go like this. Okay, and this. Okay. So this is your feet per feet per teeth. Okay, and this is your um, angle of contact angle by the contact arc by one foot. Okay, so AB is your AB is your this AB is your nothing but AC sine beta because this angle is beta. Okay, this angle is beta, so this will be 90 minus beta, and this will be again beta. Okay, so this is AB is your approximately AC sine beta, and AC is nothing but F n by Z. Okay, and AB is uh, maximum uncut thickness. Okay, okay, T1. Okay, so T1, so T1 can be expressed as F by NZ sin beta. Okay, if D is the depth of cut, okay, total depth is this. Okay, and D by 2 is the radius of the milling cutter. Okay, then we have this D by 2 minus this D, as D by 2 minus D. Okay, and if we divide it by d by 2, then we have cos beta. So from this we can find out this beta angle and put, and then we can find out sin beta and put here. Okay. So this is your approximately it will be your 2 root d by d. Okay. So T1 will be your maximum particular will be this. Okay. So this is your maximum and average will be T maximum by 2. So you have to okay. Now we have this formula. So what we have to calculate? We have to calculate mean undeformed chip. Okay, so this is mean undeformed chip. Okay, so this by putting the values, different values, we can directly find mean undeformed chip. Okay, F is equal to 200, N is 100, Z is number of is 4, and D is 2, and capital D is 100. So this is your mean undeformed chip. Okay. Now next is your machining time for a single pass in second. Okay, so this is your machining time. So yeah, for machining, to calculate machining time, length of work is equal 200 mm. Okay, so to carry out machining, the tool has to travel by a distance equal to length plus approach. Okay, length of work is plus approach, and approach is just given by approach is nothing but if we start machining, start go from here, then the workpiece has to approach, workpiece cutter has to approach to the distance. Okay, so the approach distance will be here. Or remember the formula for approach B minus D 2. Okay, that we have derived in previous papers also. Okay, so approach is just this. Okay, so this is the total distance that our job has to travel or the cutter has to travel. Okay, so this is distance travel. Okay, and feet per per minute is given by 200. So machining time is given. This to answer is 55.697 or 56. Okay, okay. Next, 52 and 53. In an ADM process using RC relaxation circuit, a 12 mm diameter through hole is made in a steel plate of 50 mm thickness using graphite tool and kerosene as direct factor. Assume the discharge time to be negligible. Okay, discharge time to be negligible. The machining is carried out under the following conditions. Okay. Resistance 40 ohm, capacitance 20 microfarad, high voltage 220 volt, discharge voltage 110 volt, time for one cycle is milliseconds, and average power input. Okay. So this is the RC relaxation circuit. Okay. Here the charging of the capacitor is given by this relationship. Here V naught is supply voltage, V is the charge voltage. Okay. And T is time, R is resistance, and C is capacitance. Okay. So, so, so when the to carry out the charge to carry out charging, so sorry, when the capacitor is fully charged, okay, then the V is your VD, okay, voltage required for the VD is your voltage required for the spark, and this is supply voltage, okay, and R is given as 40 ohm, and C is your 20 microfarad, and V naught is your supply voltage, that is 220, and VD is the discharge voltage 110, and from this we can calculate TC. So TC is your, so from this relation we can find out TC. TC is your 0.5545 milliseconds. Okay. Okay. So this is your 0.5545 milliseconds. Okay. So as we have to neglect that charge time. Okay. So we will consider only the charging time. Okay. So answer will be your charging time. TC is your charging time. Okay. So answer is your 0.5545 milliseconds. Okay. Next, average power input. Okay. So average power on input is your nothing but half into C into V D square. Okay. So this is the amount of energy released. Okay, and time is your this energy, and where time is your power. So C is your 20 into 10 to the power 6, and BD is your 110. This is your energy, and this is time is your TC. Because we have to calculate the discharge time. So this is your cycle time. So answer is your 218.24. So answer is 0.218, option C. In kilowatt it is 0.1. Okay. Next, in a particular year, an organization earns cash revenue of rupees 200,000. The tool, material, and labor expenses are 109,000. The depreciation claim on the equipment is rupees 25,000. The tax rate is 20%. The profit after tax PAT is option A rupees 92800, B rupees 66200, C rupees 72800, D rupees 5280. Net cash flow is option A rupees 97800, B rupees 77800, C rupees 66,000, and D rupees 72,800. Now the cash revenue is your 200,000. Okay, and material and labor expenses is this 109,000. Okay, and depreciation is your 2,500. Okay, so the tax on which, so the amount on which the tax is to pay. This is the cash revenue. Okay, minus this, minus depreciation. So this is the amount on which the tax has to be paid, and tax rate is your 20%. So the tax is your 13200. Okay, so this is your tax. Okay, and this is uh, this is the difference of money spent and money. Uh, this is the difference of total sale minus money spent. This is the money spent or money invested. Okay, so this is your 66,000 minus the tax. Okay, so the profit is your nothing but the difference of revenue minus expenses minus depreciation minus tax. So this is your 52,800. Okay. So answer is 52,800, option B. Okay. Now the cash flow does not involve any depreciation. Okay. So here in this, depreciation is also involved because we have calculated this 66,000 by considering 25%. So if it doesn't consider 25%, we add it back, then this is the net cash flow. So this is 77800. So answer is B. Okay. Thank you very much.